Hello team, my name is Mahesh. So in this video, we are looking into how we can reduce the Docker image size. So if you see the previous CI/CD builds that we have created, so you will notice the image size will like image size will automatically get grow up when you're building the application, when you adding multiple stage to the pipelines, when you copy some code to the Docker container itself, or you can install some kind of a dependencies in the Docker itself. So eventually your image size will get a 2 GB or 1.5 GB, and it can cost your deployment times, it can cost your system resources, it can cost your storage. Like eventually when you build the such larger amount of a Docker image, so you need to store it somewhere as well. You need to like for that, you will require extra amount of space. So by using some techniques, we can reduce the Docker image size by we can almost reduce the size by 97%. It can be easily possible with the possible throughout the multiple steps that that we will explore in the practical way. What is the need to reduce the Docker image size? So, to increase the deployment cycles or increase the time while deploying a new version or the new applications. So throughout that, we can use the newer builds or newer images to basically to build a newer images. We can reduce the time of the building and all the deployment process. It can also save the money as well as some costs like related to the storage, related to the performance of the application, related to the security part of the application. So there are multiple things that might get with the security of. So also it can improve the application responsiveness while it is being a very minimalistic OS. So throughout that we can get this we can use some of the practical ways to reduce the Docker image size. So I have my local machine over here which is running on Ubuntu, and it has also installed the Docker by default. So there are multiple ways to do that. We'll look from the bloated image to the multi-stage or multi-pipeline image, multi-stage image with the using the Alpine image, with the base image, with the scratch image. There are multiple ways you can do that. But first thing we can see what is a bloated image. What bloated image affects in the size of a Docker. So I have created a folder called bloated, and inside this, let me create one Docker file. So inside this Docker file, okay, so let's create our first file. So in this file, we are using the Python image. So the Python, I can say 3.9 version I will require. And the work dir slash app, from the application, it will copy. From the copy, I will copy the Python application that I have to the uh, container itself. And with the CMD, I'll just run that application. So this is the basic Docker file that we have written. So it doesn't cost us like much more. So with the Python, I just run a Python main.py, and throughout that, let me save this main.py, and inside this I'll just write. So if we can see, we have created a two files, particularly in the Docker file itself. We have written with the Python 3.9 version, which is a full version of the Python. It will around a 300 400 MB, and throughout that it will copy the our main file. Basically, we are setting up the work file as a app. After that, we'll just copy the main.py into the that work directory, and after that we'll run the application. So with the Docker build command, we'll just build the Docker image, and we'll call this as bloated image colon v1. So throughout that we can keep track of it and dot. So it is building the Python image. So from the scratch it will download the Python image. So if you can see in the first glance, it will is downloading the 48 MB package. After that 23 MB, 64 MB. So it is downloading the libraries or the packages from the Python itself, and it will take a little time to compile the Docker file. So just wait for a second. Okay, the Docker image has successfully built, and it has tagged with the bloated image version 1. So if you can see Docker images, so you'll see this image will cost us around 999 MB. So it is almost 1 GB of image. So if you can run with the Docker run, you will see with for to run a single command, it has taken around 1 GB of space. So with the from the disk itself. So if you can see, we have just printed this particular message, and we have for temporary we have run this Docker image. So the application is successfully working. In the second stage, uh, we can see what is a multi-stage Docker. So in this case, we have used. Let me show it to you. So in this case, there is a major disadvantage. We have used the Python 3.9 as a base image. So it is a full image that we have used for the Python 3.9. First issue was that the Python 3.9 has a like slightly because it in the comparison we don't need to require that much libraries. Second, the point is it has insufficient layer caching. So suppose for the for the each and every layer of this particular application, such as the workday directory has a particular layer, a copy has a particular layer, there is another blank layer with the cmd layer or the from the keyword layer. Each and every layer will consume a little amount of space, as well as it will also consume the it will also affect the build times and all. So like it is recommended to use a multi like backward slash or add multiple commands in substitution of a single command. So in the later part we will see how we can do that, but the major disadvantage of the major disadvantages that we have seen, which is the image size. So this is the main purpose. So again, let's create one folder called multi multi-staged VM Docker file. So let's write a Docker file. So in the multi-stage, what we can do? So we can use a as we have created a bloated image. So multi-stage will win in this point. So if we use from keyword from Python 3.9 image, I'm using the same image again, but I'm using the slim version of it. So what the slim version? It is like it is a very like very less in terms of the size of the Docker base 3.9. So I'm utilizing the multi-stage command. So in the first stage, I have called the alias, or we can say name to call it later. We have used the as keyword, and from there we are like running some commands. So by using the run, I'm just saying apt-get install. I can say uh, Flask. So the Flask that we will require to run this particular application that I have right now. After that, I'm setting a work dir. So which is the app. You can set whatever it is. With the copy, I'm just giving a little space so you can get the difference. So I'm just copying all those files to the work directory. After that, not the word directory, I need to just copy to the slash app. After that, I will require to run one command to do pip. Okay. So as we have used the Docker Slim image in the first stage, we have installed the Flask. Also, we need to run another command called pip install -r requirements.txt. So the requirement.txt will contain the required packages that will require by the application. And yeah, so that's it. So another stage we are using the from here. In the from we are using the another keyword called another image called we can so 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 what we have to do here. So by using the Python, I need to again install use the same Python version, or to reduce the size drastically, I can have also I can say distroless images. I haven't covered this topic yet, but the distroless images, what it will do, there are several distroless images which is pre-created by it. So if you can see the Python 3, so the distroless images has already created. So let me go on the build, not the build. This is the distroless image that I can use. From this image, I just need to copy from my local to the application folder. After that, what I have to do, uh, I need to use the hyphen from builder. So I'm copying the required, I can say, files or things from my builder to my applications folder. So once I copy that, I just need to use the entry point as a, not entry point. I need to run some several commands again for to run that application. So I just integrate with this only. So pip pip install like, double and to do command substitution. I have just did that, told you about that. To if you like merge the two commands or the three commands together, so it will also reduce some amount of the space from the disk, as well as it will improve the performance, because it has we have like use the command substitution to reduce the size of the image. So it can, for the larger images, it can drastically I can say reduce the Docker image size. So in the install as well, we need to use the no cache dir cache directory hyphen r requirements.txt. Everything looks fine. Just I need to use the cmd to run the application. Cmd python 3 comma app.py app.py. So everything looks good to me. Uh, for to application, we have added the, I can say, requirements.txt and application.txt. If you can go in the repository, you will find out the Python application. So if you can search for the simple Python app, there is a repository which is already created. So you need to do, I just copying the like applications from here. So I just need to create app.py. So in the app.py, I need to use, I'm just said paste. Yeah. So in the Python, I have just added. So I need to expose the port 5000 as well. So if you can see in the app.py, there is a port 5000 port that we will require. So in the vim docker file, expose port 5000. Yeah. So the port has been exposed. After that, we need to use the requirements.txt. Vim requirements.txt. So in the requirements.txt, we need to copy the requirements.txt from the repository as well. Once we've done that, just save and quit the file. We can use the docker build -t. This will call as a multi-stage distroless colon v2 dot. So this will build the Docker image for us, and let's see how much it will how much storage it will take us to build this particular image. Okay, so it not able to detect the Flask application. There is some issue in the Docker file. So let me remove that particular column from the Docker file. I have added to increase the layer to reduce the layer caching. So just let me run the pipeline again. So it is saying you need to hyphen update. So there is some issue related to the port 2. Let me see. It, it's not update, it's upgrade. So I'm just upgrading the existing I can say module pip that I have upgrade. And yeah, so let's see now. Yeah, it is now installing the things. So it haven't found the requirements.txt. Return on zero value could not open the requirements.txt. No issue. We have made the syntactical error in that. So let me update that Docker file. Also, before that, there is one thing we need to copy the directory to the app. So after that, we can install the Docker file. So let me see it again. Yeah, there was some issue related to the syntax, and it is now building that Docker image. So I have put the unwanted space in the Docker file, so because of which in this error get happened. So yeah, the Docker image has successfully built with the multi-stage distro list version 2. And if you can see the Docker image's size, so you can see you have drastically removed. So first is the image that you have created, which is the 3 point around this one. So we have created a 99 one around 1 GB. So you have drastically removed it. It is almost 200 MBs. So the overall the size of the size of the image that you have reduced with the Docker run. Let's try to run this Docker image with the port 5000. It will listen on port 5000 and with the version 2. Okay, okay. So it is running on port 5000. Just let me duplicate this session and log in as a Ubuntu. So I can also able to access the same website on the browser itself. So if I can go with the browser 104 colon 5000. So let me see that. Ubuntu. Let me duplicate. Yeah, I have successfully logged in. Let me just do curl http colon slash slash localhost colon port 5000 slash user, not the user. It is a as a written in the Python application, I can say. So let me go to that Python application. It is saying a user, not users, user. It is failed to connect because I haven't exposed the port. That is might be the reason. So let me run the same command again with the port exposed 5000 and 5000. So this will expose it now. And if you can see it, I can able to successfully access the website. This I need to provide the username and parameters. The rest of the parameters are written in the Python image. So throughout that, I can able to like access the rest of the application. So this is the overall thing, and you can see the overall logs it's get printed, and it is saying a 2004 slash user. So this is how you can utilize the distroless images to reduce the size of the Docker file. The third stage that we can use, the third stage that we can use, just let me create another one folder called multi stage go. So I'm just creating another folder called multi-stage Go. So with the statically typed languages such as Go such as the like which is statically typed, and it can be it like only requires just a simple runtime, and throughout that it can run on any application anywhere, regardless of the property of the machine. So with those kind of with such kind of I can say uh, applications, we can utilize the like such kind of images. So if you can go and write the Docker image, so let me use the from go lang. I guess the version 1.22 is there as build. So I'm using the Go version, as well as I'm using as well as I'm doing a multi-stage build. So I'm using the alias as a build. So the work directory I'm setting as a Go source application. I just copy all the files with the related to the application. After that, I need to run the mod, and I need to run some test on it in the pipe when the Docker build. So with the Go mod download, I'm not much familiar with the Go, so I'm just writing by looking into the documentation with the Go wet -v, and I need to run another one command called go test -v. So go test -v. So throughout that, it will also automatically like do its necessary things. After that, just I need to pass some parameters called go cgo underscore enabled is equals to 0, and go build -o for output slash go slash bin slash app. After that, I'm utilizing the distro image called Debian. So there is a Debian image, I guess, already created. So distro is Debian image, Deb, Debian 12. Yeah, so as you can see on this page, there is a Debian image which is already created. So I'm just utilizing the same one. So just use the same image. And after that, what do you need to do? Just a simple thing. You need to copy everything from the application and all those things from the build, and you just need to paste into the slash go bin app and slash. So after that, just do cmd um, double braces slash. So you just such as a Python always require a runtime. Python always require a runtime to run. But as you can see with the CMD, we can just do a slash application, and throughout that it get run. So just let me run this Docker image, Docker build. We haven't created the other files too. We'll require to create a go mod, go wet, and other directories. So let me copy the repository which I have already created in the GitHub itself. So you can the Docker file that I'm writing currently. So all those Docker files are already present on the boilerplate repository in the Docker itself. So you can just copy paste from here, and you can do modification according to your needs. So with the go mod, I need to copy that. We, uh, Go dot mod paste main dot go, which is the main logic of the application. And this is the test to do the testing on it. What is called main underscore test dot go. Main test dot go. So in this, I'm just pasting the test cases. After that, just build the Docker image. So with the Docker build -t multi stage go v2 v3. So this is the version 3 of the application, and as I have know already, it is giving me error with the multi-stage go. Now, as you can, okay, it is giving me error, unknown instruction called work on the line number 3. So let me um, go on my Docker file on the work where I have mentioned. Okay, I have mentioned a work as work dir. So now it will run. Yeah, so it is running, taking a Golang image. It will build the application in the first stage. After that, it will in the second stage, it will get the distroless images. It will copy the files. It will run the application. So just simple as it, and throughout that, we can easily with this like I can say to reduce the size of the Docker image, we can do multiple things. It will also improve the security because it doesn't have even the basic libraries of the Linux. So throughout that, we can use that. In this case, we can also use the like scratch images. Suppose you are using the currently we are using the go distroless images. You can go with the scratch images as well. So if you can see on the I have already created a repository for it with the Docker itself. You can go on a scratch and in the Docker file with the same command, with the same application, if you use the scratch images, it will drastically remove. So it will directly it will suppose your application is taking a 80 MB of storage, so it will directly move to the 8 MB or something. So it will that much it will reduce this. And you can also use the slim images, as you have seen in the previous video. You can use a slim image to reduce the site. It will automatically reduce around 200 MB. You can get the size. It depends on the application to application, and depending upon the layers of the application as well. So with the Docker build, Docker run, we can run this particular application. It is saying hello world, and if you can see the Docker images, Docker images. So throughout the Docker images, we have created a version 3 of the application, and it is just a 25 MB. We have scraped, we have removed all those things. Now previously, uh, in the version 2, it is a 73 MB. After that, we have created the version 3 called with the Go application, it is a 25 MB, and in the version 1 itself, you can see it is a 999 MB. So we have drastically removed that. So let's copy the same things in the another folder. Let me create another folder in the another directory called scratch, scratch. In the scratch, I just copy all those things to the scratch. So let me go inside the scratch folder. I can get the same files. Let me do the Docker, go inside the Docker file, and I just use the Docker image as scratch. scratch. So let me build the application again. Docker build -t scrat scratch version 4. Dot. There are other ways too. You can use the Docker. Suppose the Docker is already built. So Docker images. So you can see in the version 4, it's just a 1.89 MB. So from the 99 MB, 999 MB, you have scraped this to the 1 MB. So this is a huge, like I can say, reduction in the size of a Docker image. So this is all about it. And if you want to reduce the size more, there is other options too. You can use the Docker ignore commands or those kind of things are present in the Docker. If you need a dedicated session on that, just let me know. I'll just make quickly, and just it is just simple topic. We can cover that also. Thanks for watching.